Okay, let's try this again. But this time let's try it again. Whew, all right. So what's going to happen? We're going to be talking about the abacus. And I'm a little tired. But I think I want to do is I'm trying to figure out like how to introduce abacus. So when I introduce abacus, what we're doing is we're counting on the beads. And since we're counting on the beads, we're going to be doing 1, 2, 3, 4. So notice I need to do that. Oh, yeah. Hi, Kevin. So we're counting on the abacus, and abacus is a counting tool. This counting tool also does adding, subtraction, multiplication, division. But the first thing we need to do is we need to understand what it is to count on the abacus. So notice that there is a horizontal bar. This horizontal bar is our beam. This is a this is what we know that we count. We use the beads to count on the abacus. So we know that this bead is being counted. So if you notice that this is counted, but these are not counted, right? Because nothing else is touching the horizontal bar. So because it's not touching the horizontal bar, we can actually include this one because now there's 2 beads touching the bar. So that's just 2. So if I just follow if I just find my papers, so that's 2. What am I doing? I'm trying to find papers. That's what it is. So we have our 2, and then we have 3, right? 1, 2, 3. Not a problem, right? Okay, so we got 3. There we go. We got 3. So this is 3. 1, 2, 3. And then we have 4, which is not that, which is this one. Nope, 4. So we have 4. Now, how do I know? Well, 4. 1, 2, 3, 4. These beads are touching the beam. So this beam is what tells us that's being counted, right? But notice we don't have any more beads to count to 5. What is 5? The value of 5 is this. This is 5. How do I know? Because this is the only bead touching the beam. When the bead is touching the beam, then we know that it is counted. Hi, everybody. Welcome, welcome, welcome. Good evening. It's evening for me. Good morning to everybody else who is awake, and good afternoon, depending on what time of the world it is for everybody. So this is 5. How do I know that's 5? Well, that's something that we're going to have to remember, right? So this is 5. 5 and this is 5. How do I know? Because this bead is touching this beam. When this beads are touching the beam, that means that the bead is counted. If the bead is counted, that's what we call it. So now we do 6. So we have 6. Whoa, 6. 5, 6. How do I know? Well, if the top bead is 5, then the bottom bead has a value of 1. All the bottom beads has a value of 1, so we know that this is going to be 6. If you notice, the kids will be able to, welcome, 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 the kids will be able to know that when we have the 5 and the 1 together makes 6. So it also adds a little bit to like them understanding how to add, right? So then we have 7. 7, where's 7? 7, right? We have 7. 5, 6, 7. So we know that we are going to be starting here to do the 5, 6, 7. How do I know? Well, we have the top bead is 5, and then the 2 beads are all equal to 1. But you put them together, they are 2, right? Because then we have 8. How do I know that this is 8? Because it's 5 and 3. 5 and 3 is 8. We know that this is 8. So we have 5, 6, 7, 8. We also do some counting on 5, 6, 7, 8, and then we have 9. 5, 6, 7, 8, 9. So what happens after that? Well, if you notice, this is 9, this is 9, this is 9, this is 9, this is 9. Well, how do I know what 10 is? Well, just like how we write, it says, what are we talking about? We're talking about the abacus, and we're counting on the abacus. So notice that when we write, we have 1 and a 0. If I'm here, I have my 1 and my 0. My 1s and my 10s, my 100s, my 1000s, and my 10,000. So if I look at it, this is my 1s. Just like how we write it, we would do this. So it'd be 1s and 10s. So this is my 1, right? This is my 10s, and this is my 1. So this number is 10. How do I know? Well, if this is 9, then doing this is 10. Notice that there's the 1 bead touching. Like I said, what are you talking about? We're talking about the abacus. That's what I'm talking about. So we're counting on the abacus, and this abacus is what tells us what the numbers are. So when we are looking at the numbers, we have all these beads that are touching the beam. When we have the beads touching the horizontal bar, that means that this is counted. So if you look at it, what number do you think this is? If we know that these are the 1s, right? This is 11. So when we look at it, this is 12. So now we have 2 and then 3. But we add this is 13. If we did this, it's 23, right? So now if we continue to counting, this is 1, 2, 3, 4, and then we have 5. Notice that we don't have enough beads to have 5. So the top bead will always be a value of 5. So with the value of 5, we have 6, and we start counting. Now how do I know that I'm counting on this? Because if you notice, this one has a dot. This dot tells me that we're in the ones place. If you notice that there's a dot over here as well. So it doesn't actually matter which dot you're using. It just matters on what you think that the home is, right? It just matters what you think that the ones place is. So ones is over here. Do you sell children's books to learn practicing it? Yes, I saw. Yes, I saw you had 3 on Amazon. Yes. Hi, Nat. Yes. I do sell this. This is for preschool, and what this is so lesson 1 we talk about learning about the numbers and the number recognition with the numbers, right? So we have our numbers, we have our physical abacus, right? The idea was to show the physical abacus, and then this is the representation. So we have the number to understand like how it relates to the number recognition with the number with the beads with the number. So yes, I actually have 6 books. So that's one of them. And then from here, we talk about like the relationships of the numbers and the, what comes before, what comes after. This one goes all the way to 9. So we start from 0. We start from 0 and we go to 9. Why? Because I wanted to keep it into the one column. I didn't want to have to talk about what the place values are, right? So remember in our place values, we have our 1s and we have our 10s. So then this book actually stays with not to the 9. Because sometimes the kids have a problem understanding what the 5 is. So what we do is I'm trying to get them to have these exercises, these little fun activities for them to be able to recognize what the 5 is. So here is a color pixel art. And the color pixel art, I have 8, right? This is, oh no, there we go. We have 8, 6, and then who knows what this one is. If an adult wanted to learn, I'm still in the process of creating a book for adults for introduction to abacus. So what it would be still be the bead recognition, but it won't be as interactive as this. It won't be as entertaining. But I am working on it. I just haven't been able to sit down long enough to make one. Yeah, I mean, you could get a lot of, yeah. I don't know what else to say, but I do plan on making the introduction to abacus for adults. I just haven't gotten there yet. So if you want to wait, you could wait. There are others out there, but they're not as entertaining as I would make them. So the thank you so much, Nat. Yes, I do plan on making one. Because the kids. So here was the thought process. Like I actually wanted to make one that wanted to be for preschool because that was the one gap that we had because nobody ever focused on the children that are starting to learn how to count, and this is actually a great tool for learning how to count. So that's why I started here, but I do plan on doing something for still children, but if they already know how to count. So I have that, but my future, not too future distance, but my plan is to do one for adults because I wanted to start incorporating a book for adults or senior citizens, because just like we learn word search and crossword puzzles and Sudoku, I wanted to add abacus as part of the thing to ward off Alzheimer's as much as possible. So that was the plan. I actually honestly didn't think anybody would be interested. You know what I mean? This is just like I have some comments here like, oh my God, why are we talking about abacus? So I'm actually very happy, and I'm super excited that somebody's interested who's an adult to learn about abacus. And so, I mean, when I learned it, I was an adult when I learned it. I didn't learn it when I was a kid, but thank you. I do appreciate the support, and I will plan on becoming more solidified, a concrete workbook. So working on visualizing the abacus, any tips? Yeah. So the one thing would be to work out all the problems on the abacus first. So the biggest thing is to see how the beads move. So when we are looking at the abacus, right, we want to know that this is 2. And we want to know that if I move 2 beads, that's moving 2 beads. And if I move these 2 beads, so the idea is making sure that you understand when you work through problems. So here's a problem that I have. Right, here's a problem. Let me write it out. So if we had a problem, I mean, you could I mean, we're older, right? We all know how to do mental math. That's fine. But if you want to know how to do it through the abacus way, it'd be prudent for understanding how to work the numbers. So if our question is 19 plus 40, if our question is 19 plus 40, we have our 19, right? And now we have to do 40. Well, we know we don't have enough beads to add the 4. If I don't know how many people have remembered, but in school, we are teaching the children how to do 4 plus 1 is equal to 5. The reason why is because we want to utilize this 5. So if we're trying to utilize this 5, we can rearrange this equation and we can isolate the variable. When we isolate the variable, we could do plus the 5 is equal plus 4 is equal to plus the 5 minus 1. So, oh, you bought one for your child. That's fantastic. Yes. And depending on how old your child is. How old is your? Yes, thank you, Isaiah. So so going back, right. So going back, if I want to add 4, all I need to do is I want to plus the 5. I don't know if you can see that. Plus the 5 and then take away the 1. So my answer is 59, which, we could do in our head. But if you want to know how to do it through the abacus way, I would suggest going through the motions of moving the beads, right? I wouldn't do, if I had a bunch of questions like 2 plus 2 plus 2 plus 2, let's say, right? If I had this, I wouldn't be like, oh, that's 8. What I would do is okay, 2 plus another 2 plus this 2. Right? We're in this one. Notice I don't have enough beads to add the 2. So what do? Remember our 5 formula. Do you know what our 5 formula is? If I do 3 plus 2 is equal to 5, this is the variable that we're trying to isolate. So what are we going to do? We're going to plus the 5, take away the 3. See, notice that we go through the motions. Not necessarily we know like, oh, this is 4 times 8, this is 4 times 2. So to visualize the abacus, I would typically go through the motions of adding and subtracting, no matter how simple it is, honestly. Because then, as you go through the motions, you'll start seeing patterns. So notice that there's a 4 plus the 4 is equal plus the 5 minus 1. If you notice, when we plus the 5 and then take away the 1, there is this number pattern that happens. How old is your child, Tropical Mermaid? So notice that there's this pattern, right? So this is adding the 4. You're going to see more number patterns as you work with it. So even when we do 9, right? We do 9 plus 9, right? And if we do 9 plus 9, oh, okay, that's fantastic. 9, so if we add 9 plus 9, obviously we could do our doubles, right? I don't know. I know when I was a kid, I had to memorize doubles. So we know that this is 18. But on the abacus, we know that this is 9 equals plus the 10 minus the 1. And you'll notice there's a number pattern. If I want to add the 9, I plus the 10 minus the 1. So that is the number pattern that you'll get to understand. So that's why you work through the problems. So I hope that helps, Isaiah, understanding how to visualize the abacus. And when you go further, if you wanted to, you can, I had it, there's a picture of an abacus. Where did I put it? I had it. Now what I needed, I don't have it. You can use a picture of the abacus. Goodness. Where did it go? I'm trying to find my picture of my abacus, and I can't find my picture of my abacus because I lost it. How did I lose it? I just had it. Okay. So what does that mean? There was no, I can't now. I just really need to find one. I can't find it. Did I drop it? So okay. Well, I'm gonna keep going. but I do feel like I want to find this. Now I really have this need to find it. All right. So going back to what we were talking about now, the reason why learning abacus is a different way, because in abacus we actually have it structured in a specific way. If you notice, the green is simple. Is there worksheets or something you recommend I practice with when mine comes in the mail? Yeah, you know what? You can sign up for getting this addition table. That would be the easiest, because it's color coded and seeing how the numbers are. So this is green, and the reason why it's green is because it's simple. And so you'll get to see what I mean. So when we do this, we do 1 plus 3, right? And so then the question is like here, 2 plus 2. So I mean, that's like really simple. And then I have it in the back, not this one, but I have it in the back where there's the subtraction. So subtraction is the same way, where, you know, we have 8, right? We have 8, take away 2. So we have 8 and we take away 2. So I mean, this would be one of the things. Like all you got to do is sign up on my website. You know what? Message me and I'll send you the link. It looks blue. It could be blue. It's my printer and the way how it reflects, because depending on what I do with this camera. So, but the color here is meant that it's meant to be different colors in general. So this here is all considered simple. So if you notice, we do 7 and then take away 5. Notice 7 and take away 5. Minus the 5 is simple. How do I know? Because there's no formula that needs to happen. All I got to do is just take it away. Does that make sense? So this is the plus 5 formula, just as we did here, right? This is our plus 5 formula. Plus 5 formula is when we start doing this sort of adding and subtracting. So now you'll see the numbers, and as you go through the actual table, you'll see that there's a pattern, and this is the pattern. So if you continue on, I don't have my other ones because I'm not as organized as I think I am. So like here, notice there's the pink, right? Why not the second row to the right? Oh, this one? So in our columns, why not over here? Why is there 7? Why are you going to 7 there? Oh, I go 7 here because I have my dot. So when you notice on your abacus, you'll see that there's a dot, and this dot is your place value for your ones. So notice that there's a dot here and then there's a dot here. It doesn't matter which dot you use. It just matters what you considered where the ones is, right? And so if we wanted, I usually start here because I want because the numbers that we're dealing with will be big, right? Because we have our ones, tens, hundred, thousands, 10,000s. And then what's after that would be our decimal. Notice when we write our decimal, $3.25, this decimal doesn't take a place value. So that sits between the two decimals, sits between the two columns here. So we have $3.25. Yeah. Yeah. Because that's the other thing. Depending on what kind of abacus you got, like this one's a bigger one. This one is 13 columns. This one's only 7 columns. So now if it's this big, if it's a 13 column, I would start in the middle. So notice there's like there's a dot here and then there's a dot on this side. The ideas of the dots is to know where our major category is, right? So if the number is big, I know that if I start in the middle, this will be the thousands. How do I know? Well, it's one of those things, right? Like just like how we write the thousands, we do 3,025, right? So it'd be the same thing because we have our comma. In America, we use a comma. We can do 3,000 because I'm over here. 3,025. So this is my ones, my tens, my ones, tens, hundred, thousands. So that's why there's so many dots. So it helps us recognize what number is afterwards, if that makes sense. That's, oh, you got the 13 one? Yeah, the 13 one will grow nicely. So this one actually grows really well to like 5th grade because you can do multiplication and division. When you do multiplication and division, you know, depending on where you are, it will work out. And then, but it, you know, it's just one of those things. There's another one where it's bigger, and this is 23 columns. And the 23 columns, I mean, it's great if you're really serious, but it's like super long. I mean, it's so long. And this one's used for like big numbers, like huge. And the big numbers, I mean, I don't know how big the numbers would really get if you're going to be using it for regular school. You know what I mean? So the reason why I'm talking about Abacus and I'm telling the world about Abacus is because I do feel like that Abacus is a gateway to complex math. So in Abacus, we do substitution, just what we did here, right? So what we do, when you understand more, what we did here is we substituted this 4 with this equation. See, in Abacus world, we don't talk about equations. But what we did is we did substitution. And then, what we also did is we understand how to isolate the variable. When we isolate the variable, we think about the process. When we think about the process, we don't worry about the result. Why? Because what do they say? It's all about the journey and not about the goal. I crack myself up sometimes. Okay, because one of the videos that I was doing research. Do I have a YouTube channel? I do have a YouTube channel. It's Miss Lynette, and you can find me there. And yeah, and all I do is talk about Abacus. And even on my TikTok, all I do is talk about Abacus and how great it is. How great it is next to sliced bread. Isolating the variable. Oh, so the question. So when I was doing research, there was a question where it says 5 plus 3, and they were really focused on the result. So if I do a 5 and I add the 3, notice I have enough beats to add the 3, so it doesn't matter for us, right? But in this video, they're like, "Yay, it's 8! Whoa!" And then I'm like, "Oh, okay." And then there was the next question was 7 plus 1. Well, if you notice, we do 7 and we add the 1, and again, we have enough beats to add the 1. I sent you a message. Okay, great. Yeah. So the addition table. Thank you so much, Nat. I will send that to you when I get off this live. So again, in the video, in the video they were like, "Yay! 7 plus 1 is 8. Woo!" Okay, fine. Now the problem lied is when they talked about 4 plus 4. In school, we are taught to memorize the doubles, right? Memorize your doubles and then memorize the doubles plus 1 to if it's more, or memorize the doubles minus 1. Okay, that's fine. But notice in Abacus, we actually don't worry about the result. What we worry about is the procedure, the process. So the process is the second add-in. This add-in is what we're going to be worried about. Not worried about, but what we're concerned about and what we're going to be utilizing, right? So that's why we start learning the plus the 4 is equal to minus the 5, plus the 5 minus 1. So if you notice, here is the question, plus 4. Notice I don't have enough beats to add the 4. So what's going to happen? Well, the critical thinking is understanding that I have my simple. After simple, I have my plus the 5. So take a 1 from the 4 gives you the 5 and becomes... no, actually. What it is what we're going to do is understand the 5 formula, which is the 5 frame. In school, the children are taught that 4 plus 1 is equal to 5. So take the 1 from the 4. No, we don't want to take the 1 from the 4. What we're going to do, this is not what we're learning. What we're doing is we're doing the plus the 4 and plus 1 is equal to plus 5. So the reason why is because we want to utilize the 5. This is the 5 that we want to utilize. So what we're going to do is take away from the 5, not from the 4. Does that make sense? So what's going to happen is we're going to isolate the variable, if I should move this. So what I'm going to do is I'm going to isolate this variable. This is what we're trying to find, right? This is my question here. And so we're going to move the plus 1. We're going to move the plus 1 to the minus 1 because we need to balance the equation. When we balance the equation, we will plus the 5, take away the 1. That's what we will be doing because we add the 5 and that's what we do. We are adding the 5, but 5 is too much, so we have to take away the 1. Take away the 1 and give it to the 5. Yes, you know what? I'm so sorry. Tropical Mermaid, yes, you're absolutely right. I don't think of it that way. I don't think of it that way, but you're absolutely right because that's what it is. I put it in a equation form, and this is the equation that everybody would be memorizing. Yes, you're absolutely right. I'm so sorry, Tropical Mermaid. You're absolutely right. But it becomes 5 plus 3. Yes, we would become 8. Yes, it's just not something I understand at first reading it, but when I'm thinking about it, it's exactly what it is. No, you're absolutely right, and that's what it is because it's a 5 and a 3. You're absolutely right. No, I understand. It's just because I'm thinking and I'm talking and then I'm reading. It was a little difficult for me to comprehend. But as I thought about it some more and marinated, you're absolutely right. But you're absolutely right because we're going to take 1 from the 4 and then we add that 5. You're absolutely right. Good. I'm happy it's working. Because what? Because if you know the concept of adding the 5, right? If you know the concept of adding the 5, it's the same thing as adding a 10. But now we talk about carrying over. What does that mean? So just like how we do, let's do 8 plus 9. 8 plus 9. Now, again, if we add the 8 and want to plus the 9, the in school, we're teaching children that 9 plus 1 is equal to 10. Well, we can utilize this information. Plus the 7 minus the 10. No, actually, because we're doing the 9. So if we're doing the 9, we need to know what the partner of 9 is. So the partner of 9 is what? See, that's the result. 7 plus 10. That's that we don't want to focus on the result. We want to focus on the process, and the process is this number. Because when we start getting more numbers like 9, 8, 7, I'm sorry, 6, and then let's say 34, right? Plus the 9, right? With this, you can't talk about the result. You would talk about the process at each level, at each add-in. And then sometimes, depending on Abacus, we have, I'm trying to make it lighter. This is funny. Okay, so depending on which add-in we're at, it depends on what the process is. So if we even take it this, because in school we only teach the two add-ins, so it's easy to kind of like relate to the two, right? But let's say we take it one step further. So now we get to like, okay, I don't know if there's going to be more I don't know if there's going to be a complication because depending on how the number is. What do I mean? Sometimes within the equation, it's a two-step equation. Because when we're adding, this is the 5, right? We add the 5, right? If we can use it, we'll add the 5. This color here, this is like green or blue. This is the simple. So that means if I add the 6 and I add 2, there's no formulas. The next step is the plus 10s, right? So when I plus the 10s, plus the 10 is plus the 5 minus plus the 5 is equal to plus the 10 minus 5. So that's like a simple equation, right? Just like how we do here. We do plus 5 is equal to plus 10. When we put it in an equation, in an abacus equation, it's plus the 5 is equal to plus the 10 minus the 5, right? So now the problem is this, where it's a two-step equation. One parent was like, well, I want my child to know, how come I can't just teach my child what 8 plus 5 is and the reverse of 5 plus 8? Well, you can, but there's actually more to this because it all depends on the numbers that are happening. So if I do 8 and I want to add the 5, right? We know we can plus the 5 is equal to plus the 10 minus the 5, right? So we plus the 10 minus the 5, and it gives us 13. So we focused on, we know about this process, right? We know about this 5. So the answer is 13. The answer here is 13, but we don't worry about the answer. What we worry about is this number right here. Why? Because when we do the 5 and we add the 8, how do we do plus 8? Plus the 8 is equal to plus the 10 minus 2. So I'm going to plus the 10 and I need to take away the 2. Now we're in a two-step problem. Then it would be 5 plus 5 plus 3. Yes. Yes, it would be. That's what it would be. So going back to here, this one is a little bit more different. Why? Because now we don't have enough beats to take away the 2. So if we don't have enough beats to take away the 2, this is where we know that minus 2 minus 3, sorry, equals minus 5. So we're isolating this variable. We got to move this 3 over here. So if I rewrite it, it's minus the 2 equals minus 5 plus 3. It's exactly what you have there. Yeah, I see. And it's good. That means you have a real grasp understanding on the abacus. And that's what it is, right? So what we're going to do is we're going to plus the 10 and then minus the 5 plus the 3. Oh, so in yours, it wouldn't be 5 plus 3. It'd be 5 minus 5 plus 3. Sorry, it'd be 10 minus 5 plus 3. I think that's what it would be if I did it your way. You know what I mean? Like, I would have to think about that some more. But yeah, you would decompose. Yeah, you know, and you're absolutely right. So, and that's what it is. The kids will also decompose the numbers between three and 5. But what we teach the children is how to do the plus 10s and the plus 5s. When you have that solid, you can move it anywhere. It's like baking a cake or baking with ingredients. When you bake with ingredients like eggs and milk, if you're not lactose intolerant, you're not gluten intolerant, you know, knowing the plus 5s is like eggs, and knowing the plus 10s is like flour. And when you, depending on how you mix it together, it depends on what you're trying to do. So you can make what, cake out of it, muffins out of it, pie, you know, all sorts of things. You can make sauce out of it. So it all depends on how you use the formulas. But yeah, you could do it that way, 5 plus 5 plus 3. But I mean, that's not something that I teach. I hope that makes sense. Yeah, I mean, it that was the one thing. Like my kid was able to break it down where he knew that, you know, if I add the 5 and minus the 5, he didn't have to memorize like anything higher, which was really interesting. So I understand the way you're thinking, but it'd just be, for me, it'd be difficult to teach, just because I think it'd be difficult for other people to pick it up. There is a set formula for abacus, and so you could take up any book. You can pick up my books or any of the old books, and they all talk about the 10 frame, the plus 10s. It can be either called the family, the big friends, or the plus 10s. And then there's the 5s, which is the friends, the small friends, or the plus 5s. Hi, welcome. We're talking about the abacus. And yeah. So, I really need help in math. I'm talking about arithmetic. So, unless you want to know about how to count on the abacus, I'm not sure. I'm not doing anything like I'm 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 introducing abacus the way to go to algebra, but I don't talk about algebra. I'm sorry, I don't have, you know, or Reckon Rex. Reckon Rex are good, but Reckon Rex does like the quantity, right? So you have the 10 beads. Two, 3, 1, 2, 3, 1, 2, 4, 5, 6, 7, 8, 9, 10. You could do the Reckon Rec, but the Reckon Rec, I don't believe, does the 10 frame and the 5 frame like the Abacus does, because they're not restricted with the top bead, right? So it depends. I don't know fully how the record, like, I don't teach the record rec. I just teach abacus. I know of the record rec, just like I know of the Kramer abacus. And the Kramer abacus is usually for just the blind people or people who have hard of seeing. And what it is they make the abacus a little bit tougher to move, so then they can feel what number it is. So there is that. And the record rec is Dutch. The Kramer one is American, and this one is Japanese. And then there's the Chinese one, which is this one. I do have a Chinese abacus, and you know, in comparison, the Chinese abacus is a little bit redundant. So having said that, like, we can still count on the Chinese abacus. Like, so what I'm going to do is I would start from 1, 2, 3, 4. Ooh, 4, right? Just like on the Japanese abacus, I have 1, 2, 3, 4, and then I have 5. But notice on the Japanese abacus, this is 5. But now in the Chinese abacus, I have two ways of understanding what 5 is. It's either this or it's this. It's not a quick thinking like the Japanese one because it's not as efficient. Because your mind has to go through the fact of like, is it the 5 here or is this the 5, right? Which is fine if your number ends on 5. But now if my number ends on 5, I got to do 6, which is another step. 6 would be 1 up there, 1 here. So that's 6. On the abacus, in the Japanese abacus, this is 6. So we have 6, 7, right? 7, 8, 9, and then 10. We're back to the problem that this is no longer efficient. And it doesn't make sense because if we're talking about columns, right, we have ones, tens, hundreds, thousands. Whereas this is 10. It doesn't make sense that this is 10 because we were just at 1, right? So then this is 10, but this is 10. Okay, that's fine. But then this is also 10. So now your brain has to think, okay, which of the 10 do I have to use? So it's a little bit more it's a little bit more redundant and it's not as efficient as the Japanese one. So, and it could be the same thing with the Rec and Rec. Like it's not as efficient because I've not heard of a Rec and Rec competition, but I have heard of Japanese abacus competition, right? Those kids that do this with their fingers and they look like they're making great gang signs, it's all about moving the abacus in their mind. And so, I mean, people are like, why are they doing that? And that's, I don't know. I mean, yeah. So yeah, no, yeah, it's, I think the abacus is the greatest thing next to sliced bread. When I learned when I was older, but then when my kids were old enough and they were like 4 or 5 when I started them. I started them on Abacus, and they have a pretty good, solid understanding. I mean, this was also the time where we had to do Common Core in school, and so a lot of the parents and a lot of the kids were like, "I don't know what's going on," and so I wanted him to be able to do it in his mind. It would be a lot of practice. It would be a lot of practice, and it's not, and it can get monotonous after a while. I want they can do it after a while, but I'm not one to push them. I don't push my kids to go competition. So you could. I'm not saying it's bad. I'm just saying that's not what my goal was. My goal was just to make sure that kids have an understanding to be solid in their math foundation. And so I'm still trying to find my stupid abacus that I was, because I'm thinking that as they go through, as your son goes through, have it. The one thing that, just so you know, the one thing you're going to come up with is he's going to be like, this is boring. Why am I doing this? And so I don't know how open he is to understanding, how to move the beads, because we push the kids to really focus on the numbers, but we don't push the kids to understand quantity. Only now do they start doing like manipulatives, like doing like arrays and stuff. So if I did an array, here is two times 3, right? Here's the array. 2 times 3 is 6. So you grab it all together. So I know they're starting to do, I don't know in your area, but I know in my area they're doing more manipulatives, and it's sad that they're not utilizing the abacus, but I do understand that there's a little bit of a curve to understanding how to read the abacus, because it's not common in America to understand the abacus. Whereas, if you go to India, like they're like everybody and their grandmother knows about abacus because there's like one learning center open at every other corner. It's crazy. It's crazy how many people there are. Like, how many people? Yes, there are. I have even heard of it in algebra using manipulatives. Oh, that's really interesting. I'm surprised that they're starting to use the manipulatives for algebra. And so what I was saying, like, abacus is the actual, I feel like it's the gateway to more complex math, because in abacus, as we go through the process, we do a lot of the process and the critical thinking, and we provide a framework, right? So there's the frameworks of understanding how to do certain things, and as you have a framework built in your mind, then it'll be easier to go through and understand how to break down a specific question. So my kids, they don't actually have a problem with algebra, right? Because they see the similarities. They don't make the connection until I tell them, but they see the connection. But when I tell them, they're like, oh. Like I talk about substitution, and I talk about isolating the variable in the two-step equation. They learned all of that, right? But they learned it in the abacus method. Yeah. So, and a lot of the questions is, do I have enough beads? Can I use, what can I use? And then, what else can I use? If I cannot use the top bead, what else can I use? So, thank you, Tropical Mermaid, for this discussion. I really do appreciate it, because it's nice to know how other people think. Because I've been teaching abacus for like more than 20 years, but I've been teaching it to children, so it's not like they have anything to not argue, but comment on. You just tell them something and they'll be like, okay, okay, right? But it's nice to know how you think it, because it's like, oh, that does make a lot of sense when you're talking about the 5 plus 5 plus 3. I mean, that's fantastic. That is how my kid actually thought of it. And I was like, oh, that's brilliant. But I never restricted him on trying to think of different ways, because that's what number sense is, and that's what understanding your numbers and how everything works. So I'm bad with math? What? So I'm just trying to learn. That it sounds like that you're pretty good in math. You just don't give yourself enough credit. So, and I actually don't memorize numbers. I don't know how big like a million is. So, I mean, it's all about concept and trying to figure it out, but anyways, I don't know where I'm going with that, but I think you're doing pretty good. I mean, if you can break down this, then you'll be able to break down abacus. And so that's the thing, is like when you understand that there's the fundamentals of abacus, it'll be easy to understand that there's a process, and if you get the process, if you get through the critical analysis, then it will translate to other parts of math. So I'm still trying to find my abacus. I'm really quite upset, because it was just a printout. Oh, here it is, here it is, here it is. So depending on how far your child gets, depending on how old and how far your child gets, and if they could see this in their mind, that's fantastic. But if they can't, you can use a paper one. And this one is, the one that I made. And so it's the same thing where I want to add the 1, right? I just put my finger here. You can't move the bead, right? So the idea is to slowly get them to see the abacus in their mind. So you have the 1, you have 2, you have 3, you have 4. So I have 4 plus 4 is plus the 5 minus the 1. But don't do this until they see it here first, right? So they would do a lot of these questions on the abacus before they go into the picture. And then after the picture, then you do the question again, but you try to put it in your mind. There's a whole process on it. But I mean, it all depends on how like stringent you want your child. Oh yeah, have a good night. Thank you so much. I saved your name so I can have him go and watch your YouTube. Oh yeah, thank you so much. I do hope enjoy it. I hope you enjoy it. And good luck with the abacus. I really do think it's the greatest thing next to sliced bread. Have a good night, and I'll see you later. Bye. Thank you everybody for commenting and asking questions. Is there any other questions that I can answer about the abacus? So I knew that there was a few people that are like, why you are relearning this? I'm like, well, depending on where you are and what you want to do. I know when I was learning this, it was like, I don't even know why I'm learning this, but it was because my dad went to a business trip, and a lady, one of his colleagues, went up to him and said, you know what, this is the greatest thing. My kid is autistic. I don't remember the full story, but my kid is autistic, and he was able to be functioning because he was able to use the abacus. And it was like my dad was super super interested, but he never learned how to do the abacus, and so he told me and my brother to learn the abacus. So we learned the abacus, and we've been teaching it for about 20 plus years now. But now I'm actually on the process of putting this all online. So that's why I have my workbook, and I have I have a class, and I teach children as I tutor. I also teach children through Zoom how to use the abacus, and we just go through the process, right? So here I have like a bunch of worksheets that I've created, and I think they're pretty entertaining, and they think they're pretty entertaining as well. And then here is we talk about what's before, what's bigger than, what's less than, and then this is when we start doing this. Can you do multiply, or is it just adding and subtracting? Actually, you could do multiplication and division. We can talk about that right now. Let me finish my thought. So here in the process, what I did is, notice I have the plus 2. We want to plus the 2 because I want to show the children, I want to show the children what it's like to add the 2, and I put it and try to put it into different scenarios, right? Whereas in regular school, we talk about the answer. Okay, so that was the one thing is like, we focus on the answer, but I think what we need to do is focus on the process. So the question is multiply or divide. We can start multiplying. So in Abacus, we actually don't memorize anything higher than the tens because it's just redundant. So the first thing we can do is we can do like, I don't know, let's do 6 times 12, right? So 12 times 6. Easy. Not a problem. This is something we can, but we don't memorize this. What we do in Abacus is what we call distributive property. What does that mean? What we're going to do is we're going to take this number, we times it to here, and we're going to take this number and we times it to here. So what we're doing is we're taking it apart and then we add it together. So distributive property, I had it. It was A plus B equals A plus C. I can't. I have to go back and remember what the formula is. But this is actually what we consider distributive property. Now, before I figure that out, before I start doing the multiplication, what I need to do is I need to figure out where my starting point is. Why? Because then I know where my answers will go. I can't just go anywhere in the abacus because depending on what the columns is, you might have too many zeros or not enough zeros, and then you get decimals, right? So before we could do it from here and then go out, but I didn't learn it that way. I learned it from going from the outside in. So the first thing we're going to do is we're going to figure out our starting point. To do that, we need to count our digits. We have 1, 2, 3. So I have 3 digits. I'm going to start in the third column. I'm going to start in the hundreds column. So the first thing we do is 6. 1 times 6 is equal to 6. We're going to change this and make it into a double digit so there's a leading 0. If there's a leading 0, we know that this is 0, and we're going to put this as a 6. Right? So now what we're going to do is we're going to do 2 times 6. 2 times 6 is 12. When we do 2 times 6 is 12, all we got to do is add the 1 and then add the 2. So my answer is 72. Did that make sense? So, it's easy. As kids, when I was young, we had to memorize this. But on the abacus, we actually don't need to memorize our 12 times table because what we do, and this is a common thing, like this is what we do all the time, is what we figure out is how to do the distributive property all the time. And then because we have to do it this way, we really solidify our math fact. Hi, Micah. How are you doing? Hello. I'm so happy you're here. We're just talking about multiplication. So the other multiplication that I had, let me see if I can find it. I'm doing well. This morning was kind of like, it was kind of popping this morning and, going back and talking about the abacus, which I really like. And I'm so happy you're here. I hope if you have any questions, let me know. What we're doing is we're doing multiplication. So here is another question we have. I have 24 times 5. These are easy for us to visualize, right? Because we're adults. But through the abacus way, I think it's nice because they'll be like, oh, that makes a lot of sense. And you don't have to go through is it really this way or is it really that way? What does that mean? So here, I want to know, okay, so here's the question is, through this, where do we start our answer? Do we know how to find our starting point? Well, in the abacus world, we call it the starting point. So what is our starting point? Anybody know? In the hundreds. Yes, exactly, Micah. So we have our starting point. How do we know? We have 1, 2, 3. So we have counted 1, 2, 3. So we know that we're going to be in here on the third column. Third column from the dot. Right? So, hi, the tomato. And then what we're going to do is we're going to do 2 times 5 is equal to 10. So I add the 10. Right? The 1 and then the 0. Don't forget the 0. So I'm going to move my finger to the 0. I'm going to move my finger to the tens because that's where my 0 is, right? And then 4 times 5 is equal to 20. So again, I have my 2 and then I move to the here and it'll be 0. So my answer is 120. Yeah. So, anybody have any other questions? We can do division too. If that makes sense. We can do another multiplication question. So, let's do, you know what? Yeah. we could do another multiplication question. So another multiplication question would be this one. Let's see about this one. 76 times that by 3 is equal to what? So again, because the way we have it, we're going to start with our hundreds. 1, 2, 3. So we do this first, and then we do this. So 3 times 7 is equal to 21. So I add my 20, and then I add my 1. Remember, and then notice I move my finger to the next column, so it reminds me to start there when I do 3 times 6. 3 times 6 is 18, right? So it's 1 and then 8. Yeah. So that is a multiplication. And then, yes, we can do division. We can do division. How do we do division? It's the same thing. We need to find our starting point. We're going to do simple division, right? That's something that we can like all follow along. So with the simple division, it's the same concept, but kind of different. So let's say 44, divide that by 6. So again, we're going to find our starting point. To find our starting point, what with this time, because it's division, we're actually going to take away the digits. So we have 3 digits here, and we have 1 digit here. So 3 take away 1 is equal to 2. So I'm actually going to start in my tens. This is where I'm going to put my answer. But I am going to put my dividends over here so I can do my subtraction. Just like how we do long division. Yeah, just like we do a long division. So I'm going to put my 1, 4, and 4. So my question is, before I start my question, one of the things is to compare. Which one is bigger, the dividend or the dividend or the divisor? Is the dividend is equal to 1 and the divisor is equal to 6. Which one is bigger? See, that's the other thing that I notice. In regular school, we don't have a conversation in math. We just do it. Whereas it should be a conversation, right? Who is bigger? The dividend, or the divisor? The divisor is bigger. So what we're going to do is the divisor is bigger. We're going to stay here and we're going to take 2 columns. That's one of the rules that we do. So 6 times what? 6 times what is equal to 14 or less. Okay, so what does that mean? Well, I think it's difficult to understand how many times does 6 divide into 14. I wouldn't know, but I do know 6 times 2 is equal to 12. So I know that 6 times 2 is equal to 12, because we know our multiplication table as 6 times 2 is equal to 12, right? 6 times 2 is equal to 12. So all I got to do is take away, so I add my 2 here, that's my answer, and I take away 12. I take away 1 and I take away 2. So now I put my finger here. There's still dividends available. So what are we going to do is we're going to compare again. How did you get 14? Oh, the 14 came from the 144. So what we're doing is we're taking these 2 digits and we're trying to figure out what times 6 is equal to 14 or less. That's how I got 14, because it came from the dividend. So now my dividend still has 24. So the question is, what times 6 is equal to 24 or less? So, I'm sorry, the question is, who is bigger, the dividend? Who is bigger, the dividend, which is this, right, the 2, or the divisor? Since the divisor is bigger, I put my answer here, and I'm going to take these 2 columns. That is one of the rules that we're going to be doing. So, then the question goes into what times 6 is equal to 24 or less? 4, right? 6 times 4. So I put my answer on the 4, and I take away 24. So what we just did is long division on the abacus, if that makes sense. So then I noticed, like, it makes sense to do it this way. Whereas in abacus, yeah, we do a lot of talking and discussing and have a discussion about who is bigger and what we're trying to do. So let's say if the number, I'm trying to think. Oh, okay. So here's another question. So here's another, yeah. So let me do this one. 69 divided by 3, right? I like it like this. 16, right. So, oh, sorry, 9, right? So now the question is, the dividend is 3. No, the divisor is 3. The dividend is higher, right? Because 6 is bigger than 3. So again, we're going to do the same thing. We got to figure out where our starting point is. Our starting... Oh, wait, so what's the answer? So the answer was 24. Yeah. So if I look at it... Sorry. Sorry, Annie. So we do, so let's do it again. We have 3, take away 1 is 2. 1, 2. So then 2 times 6 times 2 is 14. So I do 4, 4, 1, 4, 4. So 6 here. No, sorry. 2 here, because that's my answer. Take away 12. And then, yeah, so it's 24. So the answer is 24, because this is my 1s and this is my 10s. This is 2 and this is 4. Anything touching the beam is being counted. Yes, thank you. So this one was if the dividend is bigger than the divisor. If the dividend is bigger than the divisor, whew, we actually have to skip one column, and we only utilize one, and we only take away the one column. But the first thing we need to do is figure out where we're going to start. So we have 2 here, 1 here. 2 take away 1 is 1. So this is where we're going to put our answer. If we're going to put our answer here, we're going to put our dividend here. So we put 6 and then 9. Wait, can you rewrite the problem, please? Oh, okay. You know what? Let me rewrite the problem. Sorry. Yeah. I get a little bit like carried away, and I'm like, okay. No, thank you so much for letting me know. Okay. So the question is 3 divided by 69. Okay? So 3 divided by 69. So this is our dividend. This is our divisor. There's 2 here and there's 1 here. So what we do, because it's dividing, we take away the numbers to see where we start. So this is going to be negative, but the idea is 1, right? So what we're going to do is we're going to start our answer on the ones column, right? This is 1. And then what we're going to do is we're going to put our dividend in the other 2 columns so we can minus it. So we have 6 and we have 9. Thank you so much for the hearts. Yeah. So I'm going to continue on. So now we have to do a comparison. We're having a discussion, right? Who is bigger? Is the dividend bigger or is the divisor bigger? If the dividend is bigger, then what we're going to do is we're going to skip this column. That's a rule. We're going to skip this column and we're going to put it here. And then we're only going to figure this out. We're only going to take this number. So 3 times what is equal to 6 or less. That's how we're going to do it. And this will be easy, right? Because we know 3 times 2 is 6. So we're going to add the 2 here, and then we take away the 6. We only take away the 1 column because we're only finding this number. So again, we have to find, we still have dividends, so we need to find, we need to compare our dividend to our divisor. Our dividend is still bigger, so we're going to skip this column and we're going to put it here. So the question is, 3 times what is equal to 9 or less? 3 times 3 is 9. So I take away the 9. The answer is not 12. The answer is 23. Yes, the answer is 23. Yes, the answer is 23. No, the answer is not 12. Oh, I see. No, this was talking about how many digits there are. So I was counting the 1 digit here and then 2 digits here. That's why it was 12. So no, this was talking about the how many digits are in the question. Because what we need to do in Abacus is we need to find our starting point. And to find our starting point, we know where we're going to put our answers and how we're going to take it away. That's why. That's why it looked like it's 12, but it's not. But yes, the answer is 23. So, I mean, we could do more, either multiplication or division, or we even do adding and subtracting. But, you know, adding and subtracting, we all kind of know, kind of, with the 5 frame and the 10 frame. It does get a little hairy because you can do other things. Here's the thing. Let me do this one. Because when it won't be even. So what about, yeah, you know what? Let's work it out. Let's try it out. It may or may not. This is not, I don't know. So let's do it. Let's do 395. So again, we figure out our starting point. It's 2 here, right? There's 2 digits here, 1 digit here. So 2 take away 1 is 1. So our starting point is 1. So we're going to put our number here. I'm going to put the dividend on my abacus so we can subtract it. Yeah, this won't work because unless you did 105, right? Because 3 times 9, well, sorry, who is bigger? The 9 is bigger. The dividend is bigger. So we're going to skip this column, and 3 times 3, right? 3 times what is equal to 9 or less? 3 times 3 is equal to 9. So then we're left with 5. But you could do this as the 10. So who is bigger? The dividend. So let me rewrite that. Let me rewrite that to a different color. Let me see. Let's do this one. So 3105, right? So again, we're going to find our starting point. Our starting point is what? We have 3 digits here. We have 1 digit here. So 3 take away 1 is equal to 2. So can you only do it if it's even? No. We can do it if it's decimals, but it gets more complicated because you don't know how far the decimals are. So it's not a problem. You could do it. I just don't have enough room. But yeah, you could do it all the way to the decimals, just like in regular math. It just depends on how far you want to go. I like it to be nice and pretty, and the reason why I like to work with even, like as it comes to even, because everybody's a beginner right now, and when you start introducing decimals, then it starts to get a little hairy. So depending on how things are. I mean, it is very much possible. It'd just be, so you have the remainders. Instead of having remainders, we would have decimals, if that makes sense. So, I mean, if you want, we can work it out. So we're back to here. We had 95. So we had 3 take away 9. So then the question would be 3 times what is equal to 5 or less? 3 times 1, right? So we add the 1 and we take away the 3. So we have 2 here. And then now it would be what times, who is bigger, who is bigger, the dividend or the divisor? The divisor is bigger. So now it's 3 times what is equal to 20 or less, 3 times what is equal to 20 or less, right? So then 3 times 6 is equal to 18. 3 times 6 is 18. So now we're going to the decimals. So I add my 6 and I take away, but I don't have enough columns, if that makes sense. Yeah, okay, so that does make sense. Yeah. You can do it. It's just it doesn't look pretty in a beginning setting, right? Because we're all just learning how to read the abacus, but 2, understanding that there are rules. There are rules in abacus that we should follow, that we need to follow in order to have a proper understanding on how things are. So yeah, no, thank you so much for the question. But yeah, it is possible. You just get remainders and you just don't know when to stop. I mean, it's still the same concept, right? So even if we did decimals, right? If we did what 0.3, not, that should be that. So 0.3 divided by, I don't know, 3, 6, whatever, 9, right? And there's a decimal here. Well, just like in regular school, move it over here, so then we move that over there, so it would be 0. So we rewrite it, it'd be like this, right? 3690, and it'd just be easier. So can you go over how to do multiplication? I'm trying to learn. Oh, yeah. So multiplication, you really need to know your multiplication fact. But all it is just a distributive property and how we do it. So one of the things that we do is, let's do something like 9. It's the same thing, not same. No, I take that back. It's not the same. Oh, okay. You know what? Let me do a comparison. So we have 97. So in regular math, in mainstream math, I'm going to call it mainstream math because that's what it is. I feel like the abacus is more like an enrichment program, but I think it should be part of the system. But that's just my opinion. Okay, so in school, right, what we do first is we do the 7 times, we do the ones first, and then we do the 9, and then we break it out. But in Abacus, what we do is we actually figure out how many digits there are, and that's where we're going to know how big our answer is. So to know how big our answer is, we need to count how many digits we have. So far, the abacus, you have to know high numbers for multiplication. So for the abacus, you have to know high numbers for multiplication? No. You just need to know your all the way to your nines timetable. That's it. You don't need to know more than that. Because if you know more than that, then it's just redundant. And it doesn't make sense. It just doesn't make sense because we don't take 12 times 4. We take 1 times 4 and then 2 times 4. Yeah. No, we only go to 9. But I know in school they make you go to 12. So like if you notice, like we don't do, yeah, so like this one, right? Our starting point is 3. So we have 3, 1, 2, 3. And my starting point is going to be here because we have an idea that it's going to be 3 to the hundreds. So then the question is just 4 times 9 is equal to 36. So I add my 30 and then I add my 6, right? So it's just like how we see it, 36. But we keep it here. You keep your finger here just so you can keep track, right? Because if I decide to go I don't know, go get a drink of water in the middle of my question, depending on how big the question is, right? And I come back and I'm like, oh, I don't remember what I did. So that's why, like, when I do my multiplication and I teach the children, put your finger here to keep track. So the next number we're going to do is 4 times 7 is equal to 28. So all I got to do is add my 20 and I add my 8. And that's it. So let me know in the chat, what number do you think this is? What is our answer? $388. Yes, exactly. 388. So let's take it one more step, right? Let's take it 2 digits times 2 digits. You know what? I'm going to use the same number, but I'm going to add one more because it's just because you already know what the number is, right? So the answer is 388, right? Okay, so let's take it again, but let's do another number. So we do 97 times that by 46, right? So now it's like, oh my God, what are we going to do? Notice we can't do 12, right? We only need to know 9. So again, what are we going to do? We need to find our starting point. Same thing. Find a starting point. There's 2 digits here. There's 2 digits here. 2 plus 2, right, is 4. So what happens? We're going to do the same thing. But now we put our finger here. 1, 2, 3, 4, right? Now, again, we do 4 times 9 is 36. So I add my 30. I add my 6. Move my finger over, right? I'm going to try to be more visual. So then 4 times 7, right? That's the next one. We do 4 times 7. So 4 times 7 is 28. So I add 20 and I add 8. Okay, we are done with the 4. That's fine. Now what do we do? Well, we got to find our starting point again. How do we do that? Well, we have our 1 digit, which is our 6, and we have our 2 digits, which is 97. So going back to the same principle is 3, right? 1, 2, 3. So I start 1, 2, 3. Notice we have to start going into adding, and we're going into more adding, like higher numbers. But it's still just understanding, if you know how to do the plus 5s and you know how to do the plus 10s, everything else is just gravy. So now 6 times 9 is equal to 54, right? Yes. So, right? So we add 5 and we add 4. So here, because we're at the 3, 1, 2, 3, we're adding 5 and we're adding 4. But notice we're at 88. So this is where we have to know our addition formulas, right? Now, I'm just going to say what the addition formula is. If I want to add the 5, it's plus the 5 is equal to plus the 10 minus 5. If we don't understand it, we can go back a step and talk about adding and subtracting. But for right now, I'm going to just I'm just going to spew out the equations. So I want to add the 5, so I'm going to add the 10 and then minus the 5. Now my next number is 4. I got to put the 4 here. To do the 4, it's plus the 4 is equal to plus the 10 minus 6. So I plus the 10 and I take away the 6. Okay, we're done. We're done with this question, which is 6 times 9. The next one is 6 times 7 is 42. So I have my 40 here, right? I add 4 and then I add 2. To add the 4, it's plus the 10 minus 6. So I add the 10 because I want to add 4 here. So I need to plus the 10. I'm laughing because it's a two-step equation. So I want to add the 10 here. There's not enough. I need to add the 5, take away the 4, and then minus the 6. And then, wait, I just lost myself. Plus the 10 minus the 6. Plus the 10 minus the 6. That doesn't make sense. Wait, I'm lost. Oh, sorry. That's wrong. It is 4 is equal to plus the 5 minus 1. There we go. Because I forgot the 5. So plus the 5 minus the 1. And then plus the 2. So I add the 2 over here. Whew, that was not too bad. So if you look, what number is that? Yeah. Okay. Yeah, I got a little bit mixed up. I didn't think. Anyways, it's difficult to teach and do. So yeah. So what number do we think this is? Right. 4,462. But notice I only need to know the 9 times table. You're absolutely right, Annie. So yeah, we only need to know our 9 times table. All the way to the 9s. That's it. That's all we need to know. Yeah, anything else after that is just redundant. But that's how we do the 2 times table. The 2 divided by the 2 times 2 digits. 2 digits times 2 digits. And it's the same thing with, the more digits, it's the same thing. It's the same process. We could do 3 digits times that by 2 digits or what have you. I don't know if you want to do that, but we could do that, or we could do math or adding and subtracting. It's all great. Okay, so can I go back to adding the 5 and the rule that you were talking about? Yes. So in adding and subtracting, what we do is we don't think about the result. What we think about is the process. So one of the things that we are trying to do is, one of the things I was doing is I was trying to do some research, like how does everybody else in the world teach math? And so one of them, like to kids, right? And knowing how they do it makes understanding how to teach abacus to people just that much easier, right? So one of the questions was 5 plus 3. And it was like, okay, we know what 5 is. We add the 5 and then we plus the 3, right? So we plus the 3. Notice, do I have enough beads to plus the 3? Yes, I do. So it's great. Our answer is 8. Woo! So in the thing, we're like, yay, it's 8. But we don't, on the abacus, we don't focus the 8. What we do focus is this 3. Okay, so that's something that we have to kind of keep in mind. So the next question was 7 plus 1. I'm like, okay, 7 plus 1, that's easy. We do 7, right? We do 7, and then we add the 1, right? And again, they're like, yay, it's 8, woo! Okay, now the next question that they come across was 4 plus 4. Now, 4 plus 4 is a little bit loaded. In abacus, we don't memorize our doubles. Doubles is a one-hit wonder. What does that mean? Well, you know your doubles. You might need to do plus 1, minus 1, whatever. But we don't memorize doubles in abacus. So back to the video, they're like, oh, 4 plus 4, you have to memorize, it's 8. Woo! Okay, whatever. But now in abacus, if you notice, we want to add the 4. So we're going to add the 4, but we don't have enough beads to add the 4. Now, what's another way to add the 4? Notice I have this 5. In school, we're starting to teach the children how to add the 5. 1, 2, 3, 4, 5. Now, what does that mean? We're teaching the children that if we want 4 plus 1 is equal to 5, or 1 plus 4 is equal to 5. So drop the 5 and minus the 1. Yes, exactly. So why is the third column, don't they have a value? The third column doesn't have a value over here because I'm not talking about this one. I'm only talking about the ones column right now. So right now we're only doing 4 4 plus 4, if that makes sense. But yeah, you're absolutely right, Annie. It's plus the 5 and then take away the 1. So that's how we do it. But then we in Abacus, what we're going to do is we're going to isolate this variable. What we do is we isolate the variable because it's doing that, and we take this 1 and we move it to the other side of the equation. So the formula in Abacus that you have to memorize is when we plus the 4, we have to plus the 5, take away the 1. That is something that we have to learn hands down, no matter what. This is something that we're going to do, right? So in Abacus, what we do is we learn the process and not the result. So that's why this question, these series of questions would never be put together in Abacus because it doesn't make sense in my head and everything happens in my head. No. So in this addition table is what I have. So in the addition table, this one here that's shaded either green or blue, this is what we considered simple because there's no formulas involved. These ones here, this pink, these are friends, or the plus 5, which means that they're the 5 frame. And that's where we start talking about, we supercharge the 5, that concept of the 5 frame. So we supercharge the 5 frame and we actually work it into our Abacus. So then, what is the yellow? This yellow is when we start talking about the 10 frame, right? How do we make a 10 and how do we utilize it? So adding the 10, so here we're having 8, right? And I want to add the 6. There's not enough beats to add the 6. So to add the 6, what is another way? Well, if we look at it, 6 plus 4 is equal to 10. Now, why do we want to do 10? Because we want to do the carry over. We want to carry over here, right? We want to carry over here to add the 6. I'm sorry, to add the 10. And then we move the 4 over to here. So we rewrite it. 6 is equal to plus the 10 minus 4. So I plus the 10, right? That's my carrying over, and I take away the 4. Again, I minus the 5 plus the 1. Yeah, minus the 4. Exactly. But notice I cannot minus the 4 because there's not enough beads. So this is where the two-step equation happens. So that's where this part happens. The two-step means that there's not enough beads to take away the 4. There's not enough beads to take away the 4, so what's another way? Another way is minus the 4 minus 1 is equal to minus 5. So I take away the 5 and I plus the 1. Yeah. So, and that's all it is. If you know your 10s, you know your 5s, you can go do everything with it because it just depends on how you mix everything up. And so those are the building blocks. You understand the building blocks. It's easy to do. It's easy to do Abacus. I do. I think it's pretty easy. I mean, there are steps and formulas to critically think about the framework. But once you figure that out, then it's really just trying to figure out where does all the pieces fit. So that's why, like, if I showed it, because that's why I have this color coded, and I see that there's a pattern. I'm like, oh my God. How come nobody taught this to me before? And it was just one of those things I just wanted to see what it would look like. And when I did it, I was like, oh my God, there's a pattern. So it's the same thing with the subtraction, right? Subtraction is the same thing. We have our 5. This is the simple, the green, the blue is the simple, and this yellow here is the minus 10s. And again, it's the same concept. This here is the two-step equation. And again, it happens again. This is the 5, but now we're at 15. So 16 take away 3. Yeah. So I thought this was kind of interesting, just to understand that there's patterns to it, and Abacus makes it easy to recognize those patterns. So that's why I would recommend understanding Abacus, just to, but I mean, do we really need it? We have calculators. Yeah, it's up to you if you want to learn it as an adult. I learned it as an adult, but I'm teaching my kids and I'm teaching. So there are formulas. Yeah, we call them formulas, but I think in the mainstream they're called equations, right? So the sets, so the only sets that you really need to know, and I'll write it up. It's going to be so easy and so it's mind blowing how little amount of memorizing you have to do. So the first thing we're going to do, right, the first thing we're going to do is we're going to do plus 4 is equal to plus 5 minus 1. And then plus 3 is equal to plus 5 minus 2. Plus 2 is equal to plus 5 minus 3. And plus 1 is equal to plus 5 minus 4. Now there's the opposite, right? The opposite is minus 4 is equal to minus 5 plus 1. Minus 3 is equal to minus 5 plus 2. Minus 2 is equal to minus 5 plus 3. And then minus 1 is equal to minus 5 plus 4. That's it. I want to learn so I can do mental math. Good luck. Do I do it? I don't do mental math. I'm still very slow, and I still need to use my abacus. As long as I've done it. I mean, I don't go out to try to. I try to do mental math, but I don't take the time to. So going back to this. So this is the 5 frame, right? This is the 5 frame, and this is how we use the plus 5. Now the next one would be the tens. Same thing. Plus 9 is equal to plus the 10 minus 1. Plus 8 is equal to plus the 10 minus 2. And it goes all the way down, right? Plus 7 is equal to plus 10 minus 3. And it goes all the way down. And it's the same thing on the other side, right? Minus 9 is equal to minus the 10 plus 1. Minus 8 is equal to minus the 10 plus 2. Minus 7 is equal to minus the 10 plus 3. And you go all the way down. And that's it. That's all you need to know. Now, the thing is all you got to do is make sure you kind of push it all, how do they all fit together? And that's it. Yeah. Yeah. It's just one of those things. So, I mean, I can continue on with like 6. So 6 is plus the 10 minus 4. Plus 5 is plus the 10 minus 5. Plus 4 is different. Why? Because it's plus the 10 minus 6. If you notice, if I do 8 plus 4, I'm already using the 5, so I cannot take away the 4. Yes, how would it work with 2 digits of subtraction? With subtraction. Same thing. Same thing. Subtraction. So give me a number. Give me a subtraction number. And I will tell you the answer. Because it's I got to do 4, and then plus minus the 5 is equal to minus the 10 plus the 5. Yeah. Okay. So here's the question. Thank you so much for the question. It's less for me to think. So, all right. So we have 45 take away 16, right? So, I mean, we could do the beads, right? We could do, take out the beads and stuff, or we can do it on the abacus. So, the first thing we're going to do in abacus, we actually do the whole number and we do a takeaway. That's the understanding, right? So when we do subtraction, we always go by the whole number. We don't do the ones first and we don't do the tens because we don't have to. That's not the way we do it. So we're going to add the 4 and we're going to add the 5, right? Oh yeah, because the 4 digits. No. So because we're doing a subtraction, this is the ones, right? And this is the tens. It's different than if we were doing multiplication and division. In multiplication and division, that's when we have to figure out our place value. But when we're doing the adding and subtracting, it's only the multiplication and the division because we're now doing fast adding and fast subtracting, right? So when we do the adding and subtracting on the abacus, and you have to line it up nicely, right, in order to see the numbers. Actually, you don't need to. Thinking about it, you don't need to line it up nicely because we always do by the whole number. Okay, so I have my question 45. So I add 45 on the abacus. Can you see that? Yeah. So now we have to take away 16. I take away 1, and I need to take away 6. Is there enough beads to take away 6? No. So what's another way to take away 6? Minus the 6. Whoa, minus the 6 is equal minus the 10 plus the 4. So that's all we need to do. So we need to take away the 6, or take away the 10, and we add the 4. Just like that. That's it. So our answer is 29. Yeah. if that makes sense. Yeah, exactly, 29. Thank you. Thank you, Annie. Right? So, I mean, it's easy because we starting to understand that when we do the plus tens, yeah, that's what I'm saying. It's like the greatest thing next to sliced bread. Because you can see it too, right? You could see it. So we have the 4 and we have the 5. Well, we want to take away the 10. We want to take away this 1. So we take away the 1, right? And then don't forget, we do the whole number. So, and then we take away the 6. So we take away the 10 and we add the 4. But let me tell you, in Abacus, we don't have just 2 add-ins. We have like a lot of add-ins. So let's do a harder question. Let's see what number this is. So we could do 72 plus 20 minus 91, right? I was so confused before. I didn't know that there was equations. It makes things, yes, that's what I mean. That's what I mean. Okay, so, and that's why it's like, I try to tread lightly when we talk about multiplication division, because you really need to know the addition and the subtraction. Once that's solid, once this is understood, then it's fine to go further on. But then division has its own set of rules that is a little bit, it can get really complicated quick. So that's why I have to be careful with the division. So let's start with this one. So notice in this one we have 3 add-ins. I don't even know if this is called an add-in because it's a subtraction. So is it called a third subtracted? I don't know. I don't know the terminologies. I just know that I have a bunch of questions. So here I'm going to do 72. So I add my 70 and I add my 2. Oh, it is? Okay. Okay. So now notice when I look at it, I don't do like the tens first and the ones. I do the whole number. I do this whole number. So I add the 20 and I add the 0. And then now I have to minus the 91. So I take away the 9, right? Take away the 9 and then take away the 1. Oh, my answer is 1. That was easy. Yeah. So let me see if I can find another question. There. Okay, let's try this one. Yeah. So we do another one. Let's do another one. 84 plus 76 plus 21. Okay. So again, we go. So it's kind of nice with the abacus because you can line it up. So usually when I do longer numbers, I line it up. So all I see is the number here, right? So I do 80. That's to help keep track. I have 80 and I have 4. Now I go down a little bit and now I know I need to add 76. So I add 7, right? Plus 7, there's not enough. So what do? Plus 7 is equal to plus the 10 minus 3. So I plus the 10 and I take away the 3. Now my next one is 6. So I need to plus the 10, take away 4. Yeah. And then I move my abacus down just to show my next number. So I add 21. I add 20, and then I add 1. And my answer is, what's my answer? Can you see that? Yeah, it's easier because you could see how the numbers move. But again, I mean, it takes a while for you to visualize it. 181. 181. Yes, exactly. 181. It does from if you can visualize it, that's great. I mean, it took me a long time to visualize it. And even yet, I don't do mental math. I can teach it, but I don't do it. I don't practice it. And it's a lot about practicing, right? I don't practice it, but you can. You can do it. It is possible. I just choose not to. I mean, it is what it is. Because, for me, what I'm trying to do is I'm trying to focus in on how to make activities. So this is my book for the plus 10s. And then I have a book for the plus 5s. And I got to create another book that's the minus 5s. And so I'm kind of like falling behind a little bit. And I have people already buying. They've already bought like their set. So I know when they do the +5, they're going to be doing the -5, but I haven't built my book yet. And so here, what I was trying to do is I was trying to imagine that these are children. So if you started off with the preschool one, right? If you start off with the preschool one, we end off with doing the simple stuff. Simple, which means that they already have the number. There's enough beads for it. So here we do the +8. So then when they're done with that, then they can go to the next stage, which is the +5. Knowing to do the +5, right, is the next stage. That's what this is. So I was thinking, because the children are young, they may not understand why are we adding the 5. So I made it into a little story, and we'll talk about it with this one. So here we say, okay, I want to add 2, and then I want to add the 4. Well, notice there's not enough beads to add the 4. So the what do you call it? The story that I have it is you have to go to the cats in the tree. There's always going to be 5 cats in the tree. So I go to the 5 cats in the tree and I grab 4 cats, but 1 cat runs away. So, then my answer is 6. So that was the one thing, is trying to get it to be interactive for the kids, to get them to understand what's going on. So I have this one where we talk about the cats in the tree, and that's what they're doing. They're cats in a tree. And one of my students are like, why is there cats in a tree? And I'm like, because cats like to go to trees. And, in The Incredibles, Mr. Incredible was saving a cat that was in a tree. So I said cats in a tree. But then afterwards I made was +10. The +10s was creating, this one happens to be in space. I just made it into a theme. So in this one, we can talk about like the 10 frame. And with the 10 frame, let's talk about 9. And again, it was the same thing. Like, you just color in the bars, the boxes, so you can see the 9 and you can see the 1. And the idea was to understand that we do the +10s. So what is the +10s? Well, you got to go to the asteroid belt. And the question is why do we need to go to the asteroid belt? Well, because we don't have enough. So if I have 3, if I'm in this question, I have 3. Thanks, Annie. I have 3, and I want to add 9. So what I was trying to do is I was trying to visualize, well, I would have to go to the asteroid belt, which is this, right? Which is carrying over. And then I have to take away the 1. So my answer is 12. I don't use the terminologies of carrying over because I'm assuming that they're only in kindergarten and they don't even talk about that. Yes, exactly. It is +10 minus the 1. +10 is the asteroid belt. So what I do is I would color in the 9 asteroids, and then 1 would fly away or something. But that was the idea. And then I got to continue on with my curriculum. The reason why it's not completely fleshed out is because I just started to find, my kids are older now, so I have more time to be creative. Yeah, that's what it is. Full transparency, that's what it is. When my kids were young, there was no time to do anything. Shuttling them to like between soccer and swimming and all this and that. But now they're a little bit older. I have a little bit more time, so now I want to be able to share my knowledge to the rest of the world. And so that's what it was, is to create these worksheets. And so I have other ones where I did one for Christmas, and there's Christmas one I did 0 to 20, and then with 0, yes. Is it easy to use the abacus? It's really easy to use the abacus. What do you think, Annie? Mel would like to know how easy it is. Is it easy? It's pretty easy. But the thing is there's some groundwork that you need to know. So like this one is, I love it. My little one is 5. Oh, nice. So I'm trying to learn new things. Oh, yes. You know what? Your little one, if you want to start it, there's this one which is just talking about bead recognition. And this was a lot about trying to this one was a lot about like trying to get them to do eye-hand fine motor skills. So I do like cutting and pasting, but this is just about bead recognition and number recognition. There's tracing involved as well. This one's Halloween. I mean, it's themed based, but I like it because it has like this maze. And the idea was like, do you recognize the number? This is the 9. Well, let's go to this one because it's a blank square. If it's a blank square, I want you to add dough balls to each of the square, and the idea was to try to get them to put 9 of them in one in one square. So that was the concept of like trying to make an empty square. And then the question is, do you go down for 9 or do you go across for 9? So this was a word recognition. I wanted them to go to 9. And again, to do a bead recognition to go 9 again. So this is a maze that they start from here and they move to the finish line. So it's easy. Yes, it's easy. You just need the foundation. Yeah. And so the biggest thing was, when I was learning abacus and when my kids were learning abacus, the questions were like super boring. Like it was painful. I will tell you, it was painful to get them to do questions like this. And this is like one sitting. This is 60 questions. And 60 questions is just like, oh my God, just do your work. Just do your work. And it was so painful. So now, I mean, I feel sad that my kids can't use this, but I know that the kids that do use it, if you do one page, you'll be fine. If you can do one page a day, then you'll be set to do, understanding full things. So that's what it was. Yeah. So, going back to the question, Mel, yes, on the abacus, I might get it for myself. Great. I actually enjoy I like puzzles and I like mazes and so forth. So Mel, this is the abacus, and to use the abacus, we're going to be counting anything. I don't know if Mel's still around, but I'm going to pretend if Mel's around. Okay. So yeah, So that was the other thing I have before I do that. And this is the other thing I kind of like with the plus 10. The plus 10 is my latest book, and I have it better. So here's the maze, which is kind of cool. You answer the maze, right? This is the answer is 20, so you follow the path, and then you have to answer the question here, and then figure out which answer you go, and it will take you to a path. So I like the maze. Then this one is the hidden number, and then this one is the puzzle. So here's the puzzle pieces. Answer the question and find the puzzle piece that has the answer. Okay, so going back to Mel's question, what we're going to do is we are going to count on the abacus, and after that, I think it's going to be time to go to sleep because it's 12 o'clock. But yeah, I think it was a good session. Thank you again, Annie, for the questions. This is really good. So Mel had a question like, is it easy to use? So it is easy to use. What we're going to do is we're going to count. We have 1, 2, 3, 4. Oh yeah. The 4. So how do I know that this is counted? Well, if you notice that there's this horizontal bar tells me that these beads are counted. These beads are counted. Not this one, not this one. These are all zeros, right? None of the beads are being counted. But notice there's only four beads. So to do 5, we have the value of 5, which is the top bead. The top bead will always be the value of 5. So this is 5, 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 right? But it's different because this is 5 and this is 50. And then this is 500 and this is 5,000. How do I know? Because I started here at this dot, and this dot tells me is the ones place. So at the ones place, I'm counting. So we have 5, and then we can carry on. Oh, that was the other thing, Annie. You can also show rounding up and rounding down. And that was like, oh my God. So remember when you round up or you round down, anything that's only below the horizontal bar, you round down. Anything with the horizontal bar, you round up. I thought that was cool. So going back to this, we have 5 and then we have 6. We have 5 and then 6, and then we have 7. How do I know? We have 5, 6, 7. Remember that the bottom bead all has a value of 1, and the top bead has a value of 5. So now when I look, this is 8. 5, 6, 7, 8. And then we have 9. 5, 6, 7, 8, 9. Right? And then remember, this is the ones place because this is where my dot is. My dot is where we talk about the ones place. So what's after the ones place is the tens place. So this would be 10. So now I have 10, 1, and 0. This is 11, and then this is 12. This is 13, and then 14. So notice how it's the same numbers, but in a different place value. So here I do 24, 34, and 44. So I hope that helps. Yeah. So, But yeah, my books are available on Amazon. But I do plan on making more books, and I do plan on making like I'm planning to expand more. I don't know, honestly, I don't know how big the numbers will get, and I don't know how many activities I'll be able to make, with the bigger numbers. So we'll see. It'll be an interesting journey, I'll tell you that. But right now my focus is for, children, for young children, elementary school. Because if we can get that going, then we don't have to worry about like adding and subtracting. So the idea was, when they start learning their when they start learning their adding, the preschool one, after they do the plus tens, and they do the two-step equation, after they learn how to do this, I start talking about the cumulative property. So if you think about it, if they start in preschool, let's say they're 4, it'll take them maybe a year to really understand how to count. And then I was thinking that it might take about a month to go through the plus 5. I didn't want to rush the kids. And, after that, it'll take another month to go through the plus 10s. So then, after they do that, I was in the process of actually creating the plus 3s. And the plus 3s is about the 3 times table. And I talk about the cumulative properties. So this is still a book in progress that I haven't really fully flushed out yet. And so I wanted to show that if I had one dinosaur, how many plates do I have? So let's do the question 300 minus 45. Yeah, not a problem. So that was my thought. So I just want to continue. So the idea was like, I wanted to show the cumulative property and how to do the 3. This is not necessarily abacus, but we do need to understand our multiplication facts in order to do the multiplication on the abacus. So yes, let's do the question 300 minus 45. And that will be easy. Okay, so we have our question 345 minus, right? So I'm going to use my colorful abacus because I like colors. And I'm going to do 300. 1, 2, 300. So I put 300, 0, 0. So now I'm going to do 45 minus the 4 minus the 5. I'm going to do it that way because that's how I learned it, right? We take the whole number and we talk about it 45, not 5 1s and 4 10s. We don't go backwards. We go forwards. So in abacus, we go forwards, meaning we go from the hundreds, the tens, and the ones. So the question is, take away 45. I take away 4, and I take away 5. Can I take away 4? No. So I'm going to put my finger here just to show, just for demonstration. And I go take away 4. So minus the 4 is equal to minus the 10 plus the 6. So I minus the 10, and I add the 6. That's easy. So my next number is minus 5, right? So I minus the 5 over here. So what do? Is there enough to take away the 5? No, there's not enough to take away the 5. So what do? To minus the 5, I have to minus the 10 plus the 5. Right, exactly. So I have to take away the 10 and then plus the 5. Yeah, no, I understand. Yeah, because it's just backwards. So yeah, and so my answer is 255. Yeah, there you go. I hope that made sense. But again, this is knowing the 10 frame. Sometimes the vocabulary escapes me. Yeah. But yeah, no, exactly right. Exactly. So, and that's the thing, right? The thing was, okay, for autism and other singles, okay. Yeah. So, and that was the thing, is like, as long as we could see it, we take it slow. And that's the other thing, is like, I don't want to rush, doing math and algebra and stuff. Wait, it was written wrong. That's okay. No. You're on the right track. I mean, you got the gist of it, right? So you're on the right track. So it's minus the 10 plus the 5, right? Because we always talk about adding. I never really go into minusing because I think minusing is kind of difficult. So minus the 5, minus the 10 plus the 5, or no. If you're doing the minus, it's minus. Sorry. it was related. So it's minus the 4 is equal to minus the 10 plus the 6. Yeah, because my minus sign kind of went into the equation. So it's actually minus the 4 is equal to minus the 10 plus the 6. Yeah, that's what it was. Yeah, yeah, yeah. Because Sharpies are kind of big and thick. But yeah, but again, we do the tens first, and then we do the 5. We don't do it the other way because, I mean, you could, but again, okay. You know what? Let's do it the other way. So we do 300, right? And we do 5. We take away the. It gets really complicated now. I see. So what does that mean? Well, I don't have enough beats to take away the 5. Okay, this is a little bit more advanced. I don't have enough, and I don't go backwards. I don't have enough beats to take away the 5. So what do I need to do? I need to take away the 5 is minus the 5 plus, minus the 10 plus the 5. So I minus the 10 and plus the 5. So let me add the 5 and then minus the 10. Okay, so I need to minus the 10, but there's not enough beads. What do I do here? I have to take away the 10. In order to take away the 10, minus the 10 is the same thing as minus 1. Minus 1 is minus the 10 plus the 9. So I need to take away the 10 plus the 9. And then I take away 40. Yeah, you could do it backwards, but it sounds like it's more cumbersome when you get to the higher numbers. But yeah, I mean, it is possible to do it any which way, right? But it depends on how solid you are with the equations. See how I did 3 equations? No, actually I didn't. I just needed 2 equations because this would give me a 9 and I just take away the 4. I mean, I don't know. I don't, in Abacus, I don't work backwards. If I did mainstream math, I would do backwards, if that makes sense. I mean, in my head, I know how to do it. It's just showing it on the Abacus would be one way. But yeah, so here we wouldn't do this because we would have already have the minus the 4. There's enough beats to take away the 4. The way you did it at first was easier to understand. Yeah, because it's the way we talk. Yeah. And it's the same thing. Oh, and it's the same thing with multiplication. Multiplication is the same way where we do the hundreds first to the ones. Yeah. So, was there any other questions? If not, I'm going to sign off because I've been on for about an hour and 45. Talking only about math. I love these conversations. Thank you so much, Annie, for talking with me about this. And also Mel for providing me the question, because this makes sense to me. It makes sense, like, to go which way, but I want everybody to understand what it is. I mean, obviously for those people that are open to it. So, child on the spectrum and borrowing, he struggles and still in place value. So I've had students who are on the spectrum. Did it work for them? I think it worked for them. I'm not a specialist when it comes to, children on the spectrum, but I have had students that worked with it and they use the abacus. So if you can have them, I'm not here to diagnose. I'm just here to explain that if you want to try to do the abacus with them, I think it would be a great idea. I wish I had been here sooner. Oh, I'm here every day, and this is actually my 3rd time today, because I just enjoy the conversations that when people are open to learning something new. So going back to the child on the spectrum and borrowing, if he struggles with it, you might want to have going through this process to see if this will help, right? Because it's very visual and it may work. And here's a caveat: make sure he holds the he yeah make sure he holds the abacus with his left hand, because the problem is if he moves it, then he will lose his answer and he might get upset. I know my kids got really upset when they were going through the questions and they accidentally bump it, and then all their answers are wrong. So, can you do a math problem before you go off? I'd love to see how it works. Yeah, not a problem. So, Mel, can I call you Mal? I'm not sure how the last one's. Okay, so, you could try it, and then when we do calculations, try to make them use their right hand, because they said something about the right hand and their left hemisphere. Melva. Okay, thank you, Melva. The right hand and the right hand and the left hemisphere, right? So AMA Sunshine, we will talk about how to count it. How does the abacus work? Well, the first thing we need to understand is, how do we read the abacus? So everybody needs to understand how to read the abacus before they can start doing adding and subtracting, any of the math problems. So one of the one of the things that we're going to do is we're going to understand the values of the beads. So all the values of the beads is depending on where you are with this horizontal bar. This horizontal bar is what tells me what is counted, right? So what's being counted is what touches this bar. So what's being counted right now is this one bead. So this one bead is counted, so that's one. So then we have two, and then we have three. How do I know? Because it's touching this bar. This bar also has a dot. This dot tells me that I'm at the ones place. And we're at the ones place, this is where we're going to do the ones. Because we have the ones, the tens, the hundreds, and the thousands. So we have the ones. So we have 3, right? And then we have 4. And then we have 5. If you notice, we don't have any more beads at the bottom. We need to figure out where the 5 comes from. The 5 will always be the top bead no matter what. No matter where you go. Even with the Chinese abacus, the 5, this is the 5. This happens to be 2 5s, right? And this is 5. So all of these are 5s, no matter what, right? Even on this abacus, the top bead are all 5s. So it depends on where you are. It's the location, and it's the top bead. The top bead will always have 5. So we have 5, 6, 7, 8, 9. And then we have 10. How do I know? Well, we have 1 and 0. Just like how we write 10, if I can find my paper, if we can write 10, that's what 10 would look like, right? We have our ones, we have our ones, and we have our tens. Did that make sense, AMA Sunshine? So that's the first thing that we need to do. We need to understand how to read the abacus. So if I did this, what number would that be? Great. What number would that be? 14, exactly. 14. So it's easy to read because we can also supertize, right? Now, what is supertizing? Supertizing is when you take a number and you know what it is. We don't need to count it. 1, 2, 3, 4, 5, 6. All we need to do is when you look at it, we're like, oh, this is 14. Sometimes it takes me a while to look because my eyes are old. But if I started doing that, I know that this is 29. How do I know? Because this is 9. This will always be 9. This looks like it's 8. But don't forget, I've also been doing this for quite some time. So when I look at it, I can see it. Like, it takes me a while sometimes to, like, read it. But when I look at it, I'll be like, oh, that's 8. 5 plus 3 is 8. And then there's 2. So this is 28. Right? So then we continue on. And then if we add the hundreds, and then we add the thousands. So it's nice that this there's a dot here, because that also signifies a place value, and it's easy to read that now we're at the thousands. Because if you can imagine, if there was no indications whatsoever, it's hard to figure out. Like if I start here and I do a number like this, then I have to start, okay, how many digits is that? 1, 2, 3, 4, 5, 6. So it'd be ones, tens, 100, 1,000. So this would be 3,000, right? So it's nice that the abacus, the Japanese soroban, has these markers for us to relate to. So you could start your ones. It doesn't matter where you start your ones. It just matters on making sure you understand where you start. So you could start here and you just have a really big number, or you could start here and you would have your decimals, right? So just like when we write our decimal, notice that we do 3.25. When we do 3.25, the decimal does not sit on a column. It sits in between a column, right? The ones column and the tens column. So I do 3, and I do 20, and I do 5. Right? So there's more to just like, oh, let's do a question. It's more about, well, let's understand, 1 about place value, 2 about the, the locations and stuff. if that makes sense. So the next thing we can do is we can start doing questions. So the one question would be, let's see. All right, we can do this one. This would be easy. Questions are so easy. Okay, so we'll take it slow, and I will try to talk slow. Oh, so depending on so going back, like there's my book, which is the Preschool Abacus. It's available on Amazon. You can find it with my name, and I talk about doing bead recognition first, and this was geared towards children that are 3, 4, and maybe 5. And this was to make sure that they understand what the numbers were, what it looks like on the what the numbers were on the abacus, and then what it looks like. Like I try to make it look like, what do they call it, representative. So make beads move and gave him figure out the number shown above. Okay, so here is a number. What number would that be? Let me move my stuff. What number would that be? Does the abacus come with the book? No, the abacus doesn't come with a book because yeah. I do sell the abacus on my website, and I do sell the ebook on my website if you just want an ebook. I haven't gotten to the point where I made it a package deal yet. So the answer is yes, 754. Exactly. However, that's assuming that this is my ones place. If this is my ones place over here, what would it be? That's assuming that this is my ones. But if I put my ones place, let me see if I can. Maybe that's better. Yeah. So if this is my ones, what would it be now? Yes. 0.754. Exactly. Right? So it's easy. I mean, that's why it's also good to know where we're starting and what we're doing. Oh, if you have the bigger abacus, this is a 13 column. If you have a bigger abacus, I would start in the middle. Depending on like how, excuse me, the abacus can grow with a child to about 5th grade or so. Anything higher, I don't think it would make sense because they start going into like algebra and calculus and stuff, and then they start using like graphing. Like you can't really do graphing with an abacus, right? You could do division, multiplication, adding, and subtracting, and we do like big addition. We do big multiplication and big division. You could do decimals on the abacus. I mean, my kid, when they were having problems with regular school, I would say, you know what, get the abacus out and let's work it out. And so they, once they were able to see it on the abacus, they were able to see it in school. So if you can, I would recommend trying to like convert the two, but you have to be careful because not all questions are the same. What does that mean? Well, in the abacus world, we have our different formulas, and I'm not sure where you started off with, but we have the different formulas. This one here, where you see it's like kind of greenish bluish. Let me see, kind of greenish bluish. This is what we call simple. Simple meaning, I've only used Masua. This would have made it all much easier. Yes. Abacus is like the greatest thing next to sliced bread. So going back to here, this is what we considered simple, meaning that means that they have enough beads to add. So here, we don't learn our doubles. So here it says 2 plus 2. We don't learn our doubles. What we learn is how to add the 2 and then add the 2 again. So then we get 4. Use only, oh yeah. Yeah, in the museum, yeah. But funny, in my like around here, I'm in California, and my local Chinese bank, they actually have the Chinese calculator at the teller where you put in deposit, where the deposit slips are, and there's a bunch of old Chinese people that still use the abacus, which is interesting. I thought it was interesting. Okay, so Okay, so, oh, thank you for the gifts. Thank you so much for the gifts. I didn't see that. I had something blocking. So why is done on the what on that one? Why it's done on that one? On the Chinese abacus? Because the old people knew how to do the Chinese abacus. Does the new people know how to do the Chinese abacus or the Japanese abacus? No. My kids know how to do it. But then we all have calculators, right? So, I mean, if we want to, I mean, it's always about like, what's the point? When you're older, we want to keep our mind active, just like we do word problems and Sudoku and crossword puzzles. We can do abacus because it keeps our mind specific. No, like the specific row. Oh, so this specific row, because I have my my dot here, and my dot is my ones, and that's what tells me that I want to start here. So this tells me this is the ones place, and then I can like label it all. I could start here if I wanted to, but then I'd have decimals. So if I start my ones here, these would be all my decimals. So depending on how big it is, this is why I go here, because usually the numbers that I have is bigger. Okay, what's going on? It's too bright. I'm trying to readjust. Oh, okay. Oh, yeah, yeah, because it's small. I mean, yeah, it's small, and sometimes the camera doesn't pick it up because it gets a little fuzzy. So this one has it too, but all of the abacus, all of the Japanese abacus has the dots, and so the dots help signify the location of the numbers. So if I started here in the middle, because this is a bigger abacus, I would start in the middle. I know that this is my thousands. So it's nice to have these markers like as indicators. So because I know this is my thousands, and then this is my 10,000, 100,000, billion. Billion? No, million. This would be my million, right? So yeah, it gets to a point where it's like now I got to like figure out where my names are. So ones, tens, hundreds, thousands, 10,000, 100,000, 1,000,000. Yeah. Is there significance of the colors? I just think it's pretty. I've been teaching abacus for about more than 20 years, and we've always dealt with the single colored one. And I like the colorful one for the young kids. I'm thinking young kids like 3, 4, and 5. And because my classes are online, it's easier to say to the kids, move the green bead up as opposed to move the brown bead up. Right? So it's a little bit easier for me to direct the kids to like show. But I also show my abacus when I work with them. So going back to the addition table, there's the addition table, and notice that this is the 5 formula, and it's colored specifically because there's no other way to get to this part. This is always going to be the 5 formula. And then here is the yellow. This is where we talk about the 10 formula, which is like the 10 frame. How to make a 10. 9 plus 1 is equal to 10. Yeah. So, yes, exactly, like the comma. Like the comma. Or the dot, depending on where you are in the world. I don't know how that works. But yeah, it's just like the comma. Yeah. But yeah, this is the 10 formula. And then this here is the two-step equation. So it's interesting because in algebra, we talk about two-step equations. And then and I'm going to coin the phrase abacus is the gateway to more complex math. Because why? We actually go through abacus, and there's a set of formulas, there's a set of procedures, and there's a framework to talk about, right? So in the framework, we have our 5 frame, which is how do we use the 5, which is up here, and then how we use the 10, so which is this. So we don't actually do borrowing, and we don't do carrying over. We know how to do the plus 10s, if that makes sense. So a lot of it is just understanding how do you add a 10, how do you add a 10, or how do you add a 5, and it boils down to just those simple criterias. How do you add a 5 and how do you add a 10, and then all the other things like there's a whole lot of strategies behind like we want to group and regroup and carrying over and so forth. You could do that. It's not a problem. We just don't do it. We just don't need to do it in abacus because we understand that there's these formulas. So I was writing it out. So we have these very fundamental formulas. And that's what I was writing out here. So this is the 5 frame, right? Plus 4 is equal to plus the 5 minus 1. Or we do the 10, which is adding the 10 or taking away the 10. So it's kind of like borrowing and regrouping or carrying over. But we don't say that in Abacus. We just say plus the 10 or minus the 10. So it's very simple, very basic communication. We don't talk about the other words that are the other vocabulary that's being used. I mean, when I'm looking at this, usually the children are small, right? So you're just adding more vocabulary to them. It's great. Or we could talk about, isolating the variable. I'm not going to say to a 5-year-old, let's isolate the variable. I'm going to tell the kids, you need to memorize this. You know what I mean? So when they understand this and they memorize it, they'll see the number pattern. So when you look, we're going to be adding the 4. When we add the 4, it will always be 5 minus 1. Always, always, always. Right? So you'll see anytime I do, like, say, if I did, like, I don't know, 43 plus 4, always will be like this, right? 43 plus 4. Plus the 4 is plus the 5 minus the 1. It will always be that. So, and that's the what the boiled down version. Like, if you really think about it, this is like the boiled down version, because we don't talk about like this question here, right? We don't say, okay, how do you get an 80 out of it, right? We don't do the strategies like, okay, this is 80, right? So this is 8 and then plus 4, and then this is, I don't know, 8 minus 4, right? And then this is 20 plus 1, and then this cancels out, and then we get 1, and then we don't need to do that. So here in this question, right, if I rewrite the question, what we do is we just work it out. So we have 8, 4, 7, 6, 21, right? And it's a plus. So this is what I think what new math is, because they're trying to get the kids to understand how to make a 10. This is great, not a problem. But then why don't we take what we know and make it solid? Like, we know this, right? If we know how to plus the 10, why do we have to why do we have to complicate things? That's how I see it, right? So here, now in Abacus, we don't do the ones first, and we don't do the tens later. What we do is we do the whole number, because we know numbers as whole numbers, right? So here I have 84. I add 80, and then I add 4. I'm going to move my abacus down so I can see the next question. So this also helps isolate the question. So now what I want to do is add 76. So add 70, right? I want to add 70. There's not enough. To add the 7 is equal to plus the 10 minus the 3. So I plus the 10 and I take away the 3. Now I have to add the 6. So if I plus the 6, I need to minus the 4. So I add the 6's plus the 10, take away the 4. So I'm done with 76, right? I'm done with this. Now I'm going to move my abacus down and add the 21. So all I got to do is add 20 and I add 1. And that's my answer. My answer is 181. Does that make sense? Any other questions? I've been on for 2 hours. Wonderful. Yes, I think abacus is the greatest thing next to sliced bread. I believe in it, like, hands down. If I wish I knew this when I was a kid, it would have made knowing math so much easier. But my kids benefit from it, and I'm happy about that. Are they strong in it? When do I go live? I'm trying to go live regularly, mornings at 6 a.m. Pacific Standard Time, and I'm trying to go again tonight at nighttime. I haven't figured out my schedule, but I think I'm going to try to do 6 a.m. Pacific Standard Time, so tomorrow at 6. But don't hold me on that. And then I was going to do like 10 p.m. Pacific, because I'm in California. So this is all California time. And then somewhere in between, catching it if I don't know. I haven't set a schedule yet. Because I'm still trying to understand the whole TikTok thing and going live and understanding like how to how to get people interested, because it was one of those things like I was always in a island that I would just talk about Abacus, but I talk about Abacus to children and they're like, okay, well, whatever. But I never really been able to talk and have a conversation with adults. And so I talk more to adults about Abacus and how to relate to the mainstream math. I have more ideas and more epiphanies to try to like connect everything. So there's a lot of connection between Abacus and regular school math. It's just nobody has made the effort to try to connect the two. What I mean is, like, we have all these terminologies that we never use in Abacus. We never use the word distributive property. We don't use the word five frame. Excuse me. Will it confuse children if they learn this when they go to school? No. No. How do I know? Because my sorry, my kids, because they have a strong sense of number, they have a strong sense of number skills. You can give them anything, like the new math, right? Whatever, the new math, how to group stuff. The only thing they find it's a pain in the butt because they have to show their work. Do they find it confusing? No, because the teachers give them strategies, and the kids will either know it will either connect with them or it won't connect with them. But because their math skills because their number sense is very strong with the abacus, they can be taught any other skill and it'll be fine for them. So when my kids started going to school, we started implementing Common Core. And a lot of the parents were like, oh my God, Common Core is so bad. It's just crazy. But my kids were fine because they knew how to do it. They had a really strong number sense. They were like, I don't know what the problem is. You know what I mean? So I don't think it would be a problem. Because a lot of the Common Core, I don't know where you are, but a lot of the Common Core relies, in Abacus shows it all the time. In school, they're becoming more, in school, they're showing more manipulatives, right? So they have like these items, right? They have these items now, and they have more manipulatives. They had no problem. And they give these manipulatives to the kids to be like, okay, this is what we do, or they do dots. It's the same concept, but in an abacus form. But with an abacus form, there's an actual set structure that it doesn't confuse them. Yeah, no, I totally believe in the abacus in the early childhood of learning math. So yeah, let me know if you have any questions. I do have a YouTube channel and I have a podcast. I have a website. I'm pretty much everywhere. I'm on LinkedIn, Facebook, Instagram. I'm kind of on Twitter, but not really. But I do like TikTok because I'm able to talk to adults. I can have a conversation. And yeah, and exactly like kids are not going to be like, are we going to get confused with this? I'm like, can't. Right. So it's nice to have a conversation with adults to be like, okay, let's really think about, the benefits or the cons, the pros and the cons about abacus. The cons about the abacus, that's as far as it goes. You can only do basic arithmetic, right? Adding, subtracting, multiplication, division. Those are the only things. And then decimals. You could do decimals on it. And then after that, you graduate and you go into algebra, calculus, geometry and so forth. Like, you can't really talk about a sphere on an abacus, right? Because it's just basic arithmetic. So, but yeah. All right. I mean, whew. Thank you again for the questions, and I do appreciate it. I mean, if there was any other questions, I am going to sign off. It's a little bit late, and I do plan to come back on early morning to see those people that are early risers. I love your passion. Oh, yeah, thank you. I'm very passionate about abacus. I really like it. It's like the greatest thing next to sliced bread. But I do believe abacus is the gateway to complex math. It is. I believe it's a gateway to complex math because if I think about it, we have all of these terminologies, that we never use these terminologies in algebra. We never use these terminologies in abacus, but we use them all over the place in mainstream math, right? We talk about substitution, we talk about isolation of the variable, we talk about two-step equation. We do that in abacus, but we don't label it like that. So that was the one thing, like, trying to get to understand. And that was the one thing, is like, understand the process and not the result. It's just like life, right? Figure out enjoy the journey and don't worry about the goal. But anyways, yeah, thank you so much. I do appreciate it. Thank you for the questions, and being open to learning something new, right? This is all new, and it's not like you should know it, but it's new and it's interesting. So, ooh, 4 a.m. Ooh, you're on the East Coast. Yeah, go to bed. Go to bed. So I'll see you if you want to join. I will be on. I don't know when. Go ahead and follow me. I do try to go early morning and late at night because I think I like to catch the different people. But yeah, I try to go. I try to go at least once a day, no matter what. But I haven't figured out my schedule yet. Yeah, you too, Melva. You guys are such late people. So late. I don't know why you guys are up. That was the other reason why I wasn't sure, like, to do math in the middle of the night. Cuz I was like, I don't know who's going to want to learn math in the middle of the night. But yeah, sons are having, oh yeah, oh yeah, okay. A sleep study. Oh yeah. That's interesting. My husband did one of those, a sleep study. And we found out that he has sleep apnea. So I wish you well with your son. Um, I don't know. I'm assuming you have one or two. Well, anyways. But yeah, I wish you well. If you could, try it and see if he gravitates to it. If he doesn't, then try something else. Yeah. Um, yeah. So I do have the books, and I'm starting to work on other books that are a little bit more mature. Kids that already know they're adding in, kids that already know how to count. So the only thing that stops them from really going understanding what abacus is just the bead recognition. If they know how to do the beads, then they can do the adding and subtracting. Not a problem. Yeah. All right. If there's no other questions, I'm going to sign off and you guys go to sleep. It's like morning for you now. It's time to get up. So, so I will respect your nights. Yes. Have a good night. Have a good morning. And I will see you in the next lives. Thank you again for joining me. Thank you again so much for the gifts. Thank you again for asking questions. I do enjoy the conversations. Have a good night. Have a good morning.